Welcome to all. Now, question number 53, cantilever beams with uniformly varying load represented by a trapezium. Just make a note. If the uniformly varying load represented by a trapezium is covering entire span, like, see, I'll put here. Either this way or this way, full span, either left side fixed or right side fixed. They are all covered earlier, long back, in the basic questions. Now we are going for combination of loads. So I will put partial, because why? If it is full, confusion is lesser. Confusion is more if it is partial, so partial. Okay, this question I will read by words. A cantilever beam is of length 4 meter. Next, it is fixed at the left end. It is very important. Otherwise, I have to give details only with respect to fixed end and free end. And then, when a couple is there, this couple, if it is a clockwise couple or anti-clockwise couple, here it does not matter. But when you go to SFD BMD, it matters. So therefore, see, if the cantilever is this way, a clockwise couple will give hogging BM. Same cantilever this side fixed, clockwise couple will give sagging BM. Therefore, at that time, I will explain very clearly what is the nature of the couple. Okay, now, a cantilever beam is of length 4 meter with the fixity at the left end. Okay, over. It is loaded by an uniformly varying load, which is starting at 1.1 meter from the left end or fixed end, and loaded for a length of 2.4 meter, further 2.4 meter. So, after reaching here, further 2.4 meter with intensity of 20 kN per meter at the starting point, as I mentioned, or at the left end, and 32 kN per meter at the right end. It is also loaded by an UDL of 16 kN per meter on the right side after the UVL for remaining portion, and a point load of 40 kN at the free end, right end. In addition, an anti-clockwise couple of 50 kN meter is acting between fixed end and starting of the UVL. Instead of all this data, why I am telling, because you should know how to prepare the sketch by seeing words. That's why I am telling. Usually such questions, what will be given for the beam shown in figure. Find reactions. Usual statement, fixed support A. See, this is the moment about A you have to take. These all already worth hundreds of times. I forgot to mark the reactions as usual, because first what you have to do? First you have to write all the statement and then show the reaction. See, anti-clockwise. I won't explain now why it is anti-clockwise, why reaction upward. These are all told many times earlier. People who don't follow everything, they will have difficulty. Okay. Take moment about A. Clockwise positive, 40 into 4. Clockwise, UDL. See, total load. 16 into 0.5 is the total load into 1.1 plus 2.4 is, that is 3.5. 3.5 plus half of 0.5, or you can do one thing, see I'll write here, or you can write 4 minus 0.5 by 2, both are same. Then, this I will tell last because option is there, minus 50. Then, uniformly varying load. You write complete UVL from C to D. See, this is UVL from C to D. Full UVL from C to D represented by a trapezium. In case of UVL represented by trapezium, see, the total load will be acting here, and distance from here will be, I won't write now, I will tell, say, X bar, some symbol, X bar. Start. First, total load is area of the trapezium. 20 plus 32 divided by 2 into 2.4 is the total load from C to D into, from A up to line of action, 1.1 outside, plus from here to here is your X bar. See, This term is your x bar. X bar. That is from here, this side plus twice of that side divided by this side plus that side into distance between them divided by 3. I am not explaining further because this maybe I am telling this one for 100th time now. Lastly, minus MA equal to 0, you get the value of MA 289.28 kN meter positive, sigma V0 plus VA minus 16 into 0.5, the total UDL, minus 40 minus only load 20 plus 32 divided by 2 into 2.4 equal to 0, you get VA. Right, therefore, write the sketch once again there and right there, support reactions are as shown below. This vertical reaction VA equal to 110.4 kilonewton and reacting moment MA, we took anti-clockwise, positive K means assumed direction is correct. This all beyond the limit now, MA equal to 289.28 kilonewton meter. 28. This is answer question over. Today's class and also for another 2 or 3 classes, every calculation I will write in the beginning only because I have a problem in the hand. I cannot do both hand calculation together, difficulty is there. So to save the time, everything I will calculate. Okay, now make a note. Everything is question over. Now make a note here. You, those who are serious, make a note. Suppose you understood the trapezium, still make a note to understand purpose. The uniformly varying load represented by a trapezium, we considered as it is. There are people, I told, who have difficulty for trapezium. Such people, what they do is, write the sketch once again. See, somewhere actually not required. It is also told many, many times. See here, 20 to 30, 32 is divide into rectangle and triangle. It will become this way. 20 here and 12 here. 32 minus 20 is 12 here. So write one more sketch. One rectangle and then one triangle. Out of scale, the rectangle ordinate is, this is from here to here is 12K out of scale. Now I think I should make it a little bigger because otherwise it looks very odd. See, 20 is here. Okay, now okay. Then here 12. I think I have to check the, this is 12, see, I'll put here now, this way. Just to understand, stagger the loads. Now, this 6 kN per meter, I will shift somewhere here, disturbing me. Okay. How much it is? I forgot. 16, see, so fast forgotten. 16 kN per meter. Now, see, this intensity is 20 kN per meter, rectangle 20, then remaining extra is 12 kN per meter. How I got 12, I already told. Okay, now, see, this rectangle is UDL, it is acting to center. This uniformly varying load acting here. Now, do one thing, this, see, take moment about A, 40 into 4, 20 into that UDL same, anti-clockwise 50 also same, this term will change. This term will change. That term will be plus, first this rectangle, 20 kN per meter for 2.4 meter. So clockwise, positive. 20 kN per meter for 2.4 meter is the total UDL. See, this is the UDL from C to D. You write here, UDL from C to D into, from here, 1.1 outside plus from here to here is center, 2.4 by 2 is clockwise one moment and another moment again clockwise. This uniformly varying load, half into 2.4 into 12 is the total load This is UVL total load, UVL represented by a triangle from C to D into 1.1 plus from here to here is 2 by 3 of 2.4, then as usual minus ME equal to 0, you get the value of ME. Let me just check the camera once. If it has gone beyond the right side limit, I think okay most probably. No, perfectly okay. No problem. Calculate. My guarantee, MA will come same. When you make sigma V0, see, sigma V0 plus VA minus 20 into 0.5, 16 into 0.5 UDL, 40, and then this UDL is 20 kN per meter for 2.4 meter. That is a UDL, and again minus this triangle load, half into 2.4 into 12 equal to 0. You get the value of same VA. Solve the question. Now, I will solve one more question for this one. I will maintain same type of UVL, but I will take fixed end right side. I will tell what happens at that now only. I will take fixed end here. Then when you take moment, the only change is this is 2 by 3, this will be 1 by 3. That's all. That's the only change. So I will solve that question and then give 1 or 2 extra questions for you to solve today. Then I will start important cantilever questions. Question number 54. I won't give by words. Take the question. Find reaction. This is A and that is B. AB. Okay. Now, usual statement. Fixed end at B. So VB upwards, MB clockwise. See now, why MB clockwise? Somebody may ask. See here. This UDL will create anti-clockwise. This also will create anti-clockwise. This also will create anti-clockwise. So, 3 types of loads are creating anti-clockwise. To balance, you require clockwise. But one clockwise couple is there. For that clockwise couple, you require anti-clockwise. You have to verify which is bigger. That nothing to worry. It will come in the equation. See, negative came. I set the question for negative. But at present, you take clockwise. Okay, take moment about B. I don't have to explain much now. It is same as I maintain the same pattern. Therefore, see, moment about B. Plus 250 minus 14 into 5 minus 8 plus 23 divided by 2 into 2.8 is the 1 minute. First UDL first. Minus 10 into 1.3 into 1.3 by 2 because moment about this point. Anti-clockwise. Next lastly 8 plus 23 divided by 2 into 2.8 is the total load into from here to here, that is 1.3 plus this x bar, that is 23 plus twice of 8, see finger is here, 23 plus twice of 8 divided by 23 plus 8 into 2.8 by 3 equal to 0 plus MB equal to 0. When you solve, MB will come negative. Okay, correctly solve. Sigma V0 plus VB minus 14 minus this UDL minus this UVL 8 plus 23 by 2 into 2.8 equals 0. You get VB. Once you get right, therefore, reactions at the support will be as shown below. See, VB you took upward. Answer came positive. How much? 70.4 kilonewton. Is it correct? Okay. Around 15. 50, 40. Okay, 70.1. MB, we make a note here. We took clockwise, negative came. See, I told you, this sign you should not see. You should link this MB directly to the direction here. Assumed clockwise, negative came. So, it is anti-clockwise of, now no negative sign now. Some people foolishly, they put once again negative. No, once you consider anti-clockwise, opposite direction, no negative. Kilonewton meter. Okay, solve it. Now, for those who find difficulty for trapezium, make a note here. Now I will not explain. 8 to 23. See here what I am doing. See here 8 to 23. See. Therefore, it will be a rectangle of 8. Rectangle of 8 and a triangle of here. This is 23 minus 8 is 15 kN per meter. Okay, that's the only change. Stagger the arrow mark. Now see, this load will act to center. This will act somewhere here. Moment about this point. So 1/3 will come. Okay, now take moment about B. This first line will remain same. This will change. This will change. It will come. See here. Moment about this point. UDL. 8 into 2.8 anti-clockwise minus 8 into 2.8 is the total load UDL into 1.3 plus half of 2.8. That is due to this UDL. You write here UDL from, you name the point C and D and write UDL from C to D. Again minus. Now write. We are considering UVL represented by a triangle. So half into 2.8 into 15 is the total load multiplied by moment about B 1.3 plus from here to here is 2 by 3 of 2.8. Lastly, plus MB equal to 0. Calculate. I will calculate as it is. Yes, correct. Minus 64.17. Sigma V0. This all will remain same, but this will become, see, VB minus 14 minus 10 into 1.3. Again minus 8 into 2.8. One more UDL. 2.8. Again minus this uniformly varying load. Total load. Half into 2.8 into 15 equal to 0. You get the same VA. Therefore, enter the answer. Question 54 over. Now, I will go for 55 and also this I will remove. Question 56. Simultaneously, two questions. Same thing, uniformly varying load, represented by trapezium. This time I am not explaining. I will put the question with the direct answer. But steps I will dictate. Those you should do one thing. You should solve independently. In case answer is not coming, then listen what I told. So because the same repetition. Okay, I will prepare those two questions, 55 and 56. Then I will wind up this class. Next class is very important. I am going for simple questions on cantilever, which are very, very important. And all those questions, one class I may finish up to 20 questions also, I don't know. Depends on the time. That you have to work out. Okay, now I'll prepare the last two questions. Two questions for you, correctly work out. 55 and 56. See, now, see, this question, first you copy the question. See, always, first copy the question. Copy this question also. Copy both the questions. Then, when you solve this question, fixed end here, VA will take upward. See, then you wrote the second round, not in the beginning. You consider VA upwards, MA anti-clockwise, and solve. Your VA will come positive, 242 kilonewton. MA also will come positive, 1183 kilonewton meter. This question, you take VB upward and MB clockwise. VB will come plus 198, so correct. And MB will come plus 388. Okay, now what I will do is, see, when I gave the answer here, you cannot see what I am doing. I never write anything. I take only the calculator. Look at the beam and calculate. When I start calculating, I will not go in order. I will start from here. If it comes later, brackets are required. Some people are afraid. So what they will do, where complication is there, they will do first that calculation. Okay, you do it. But I got confidence in me regarding the brackets. So now how I solve, I will explain. Take moment about A. Plus 60 into 2.5 plus 80 into 3.5 plus load. 30 plus 21 divided by 2 into 4 is the total load into 2.5 plus 1, 3.5 plus 2, 5.5. 5.5 plus this distance is 30 plus twice of 21 divided by 30 plus 21 into 4 by 3. I got MB value, sigma MA value, sigma V0 plus VA minus 60 minus 80 minus only load 30 plus 21 divided by 2 into 4, you get VA. Now, those who find difficulty, do one thing, divide. UDL of 21 and UVL 0 to 9 kN per meter. For them, the moment is only for this one, 21 into 4 into 2.3.5, 5.5 plus half of 4. Other one is half into 4 into 9 into 5.5 plus 1/3 of 4. Okay, over this question. Take moment about B. Minus 60 plus 40 divided by 2 into 3 is the total load. See? Total load into, from here, 2 plus this distance is 40 plus twice of 60 divided by 40 plus 60 into 3 divided by 3, then minus 24 into 2 into 2 by 2 plus 200 equal to 0, MB will come, sigma V0 plus VB minus 60 plus 40 divided by 2 into 3 is the total load, minus 24 into 2, you get the value of VB. Or those who find difficulty for trapezium, UDL of 40 and then UVL of 3 meter base, 20 kN per meter. Moment will be 24 into 2 into 2 by 2 anticlockwise plus 200 minus 40 into 3 into 2 plus half of 3, half into 3 into 20 into 2 plus 2/3 of 3 equal to 0. You get the MB value, sigma V0 plus VB minus 24 into 2 minus 40 into 3 minus half into 3 into 20 equal to 0. You get the value of VB. What I do, see, actually, if I am solving, I don't have to move my hand like this. I will just stand here and calculate. But for your purpose, I am using the movement of the hands. Now, question 55 over, 56 over. Almost everything is covered now. Now, see, and when I covered combination of loads, in the class I considered complications. Now, simple questions. Now, I will give marathon questions for first simply supported, first for, I will decide now. Shall I start for simply supported beams or with overhang? In an order I will start. I will decide now. Any order I will decide. Or maybe complete chapter I may cover also. Okay, I will decide and start fresh questions where question, answer, question, answer, question, answer, up to some limit. But I will limit the question to some number. In the notes, I will give much more questions. Same way, for those who are serious to work out. Okay, this class I am ending now. Next class will be most probably series of questions for you to work out. Exercise questions. I will not put number for the question. Why? I do not want to claim that I did 80 questions, 90 questions like that. Which I solved in the class, I will put numbers. So I will tell series of questions. I will put heading for you. Maybe first simply support beam. I have not decided still. I will decide and start it. Okay. Thank you. Next class we will meet.